Okay, now these are the questions on the similarity and congruence past paper questions. Now look at this question. It says A, B, and C are points in circle where AB is equal to BC. So we are given AB equal to BC. All this AB is equal to this BC. Okay, just for the reference, I'm doing this. And then it says P is the midpoint of chord AB and Q is the midpoint of chord BC. Now you must recall that if you have a circle and there is a chord, and if you draw perpendicular from the center to the chord is bisected. That means if this is a chord AB and here it is O, so this should be the midpoint. So this means that this is a right angle over here and this is a right angle over here, okay? And these are bisected, these are bisected. And then there is a second property, bacho, ke equal chords are equidistant from the center. Okay, like if there are two chords which are equal in length, they will have the same distance from the center. Therefore, you should allow me to say that this length is equal to this length. Okay. Now this will become very easy for us to prove that the triangle OAP is congruent to the triangle OCQ. Let me tell you how to show this proof, and you will have to write it in the same way to get these 3 marks. Okay, so you have to write in, please copy it down, in triangle OAP correspondence with the triangle OCQ. Now we have to show 3 measures equal to each other, including at least one angle. So first of all, I would say that um, we have OP equal to OQ. OP equal to OQ. The reason is that uh, equal chords are equal chords are equidistant equidistant from the center. You have to write this reason, but without the reason, you will not be getting the marks. Equal chords are equidistant from the center. So we have shown one measure equal to another measure. Okay. And secondly, I can say that this AP is equal to this CQ over here. Okay. So I would be writing that AP from here, that is equal to CQ in the other triangle. And the reason is that um, a perpendicular from the center, perpendicular from the center. In fact, I should say that, yeah, a perpendicular from the center bisects the chord, bisects the chord. Okay, and we know that since this was the midpoint, so there it has to be the perpendicular, so this is the bisector. So if AB and CQ, they are both equal and they have midpoints marked here, so AP should be equal to CQ. Now we have to show one more measure equal here. Okay, now what can be that measure? Can I say the angle P from here, angle OPA is equal to the angle OQC? Okay, that is equal to 90 degrees. The reason for this is a bisector from the center, a bisector from the center, let me change the color, from the center is perpendicular to the chord. Acha, I think we should have started from this. We should have told this property first, then this, and then this. This could be more logical. Anyhow, we have given 3 measures equal according to the given situation here. So hence, we can say that therefore, the triangle OAP is congruent to the triangle OCQ. But you will have to write this much. You are not required to write the stories there. Okay, You tell this side equal to this side and then mention the reason. You give another corresponding measure equal and then you give the reason for that. Okay, now when we say that these two triangles are congruent, then we can say because we had this side angle and then side, we have used it. So this is because of the side angle side property. We have shown that these two triangles, they are congruent to each other. Let me know if there is a question. Acha, from this, we get an idea. Okay, we could also say that this side from here is equal to this side. Why they are equal? They are both radii. Okay. Yeah, but it is in the triangle OPA and in the triangle OQC, you know. So then this would become the side property. Okay. So you just say that we have the radius equal, then we have this right angle maybe there, or like, you know, you can, there are many options here that you can use. Okay. So guys, let's move to the next question. I'm going to clear all of this and see what is next. Okay, this is here a question from, let me see what is the year of this question. This is from June 18, paper 22, and it is a question number 8. Okay, it says OYC is a triangle. Okay, A is the point on OY and B is the point on CY. Okay, AB is parallel to OC. AC and OB intersect at X. Okay, prove that the triangle ABX is similar to the triangle COX. You give it a try first. Remember, whenever you have to prove two triangles similar to each other, the best way is just to show two pairs of corresponding angles equal to each other. So since you people are given that AB is parallel to OC, you can say that angle A from here is equal to angle C from here, okay? And you should start saying that in triangle ABX, correspondence with the triangle COX, okay? We can say angle A from here is equal to angle C from here, and these are alternate angles. Write this in the brackets. These are alternate angles. Okay. Then we can say that this angle is equal to this angle. Angle B from here is equal to angle O from here, and you can see that A is being at the same place as C, B being at the same place as O, and then X being at the same place as X. So these are also the alternate angles. And you can also say that angle X from here, this angle is equal to this angle because these are एक तो you could say that this is understood, otherwise these are vertically opposite angles. Hence, the triangles, hence triangle ABX is similar to the triangle COX. Okay, that is how you prove that these two triangles are similar. Let me see if we have any relevant part here. Yeah, this is related to vectors, I think. So just going to leave that. So this is it from this question. Okay, it's here. So moving to the next question now. Okay, well, here we have a question from June 16 and paper 22, and it is a part of question number, the last part of question number 4.
May June 2016.
Yeah. Okay, it says trapezium this is similar to trapezium this. AB is parallel to DC. Angle AB is 90. DC is twice AB. Okay. Acha. Suppose if this is X, then this is 2X. And BC is half of AB. BC is half of AB. Acha, let me keep this as X. This will be then 2X and this will be now 4X. Acha. And PQ is 3/4 of DC. 3/4 of DC. इसका मतलब है this would be 3X. It's fine now. Okay. So it says, Oh, look at this. He has himself given this BC's X. I was assuming I didn't read. You see, you have to read the question carefully. Anyhow, I just read this at the end. Find an expression in terms of X for the area of PQRS. Now, but so remember, when you have two similar shapes, the ratio between their areas is equal to the square of the ratio of their corresponding sides. Okay. So it says find an expression in terms of X for the area of PQRX. Now you can find the area of this ABCD in terms of X first of all, or maybe let's see that. Uh, First of all, like before I find this area, you must see that since they are both similar to each other, so the ratio between their sides is 2 by 3 because this is 2x and this is 3x. Okay, so I can say that area of ABCD over area of PQRS, that is equal to 2x over 3x whole square. I can cancel out these x. Now we can find the area of ABCD. Let me find it here on the side. That is going to be half into sum of the parallel sides because it's a trapezium. So 2x plus 4x is going to be 6x and into the height that is x. So this is going to be 3x squared. So this is 3, oh sorry, let me write this with that. This is 3x squared over this area that we have to find, that is equal to 4 over 9. So this required area is going to be 27x squared over 4. Okay? So that is what we have, the area of the speech. You can just leave it like this. Okay? Uh, centimeter square. We have another suggestion here. Now, our student is saying that if this is 2x and this is 3x, so rather than using this relation over here, we could have said, okay, this is 2x, this is 3x. If this is 4x, this can be 6x. And if this is x, it's going to be 1.5x. And then you use the formula here, half into sum of parallel sides into the height, and you still get the same answer. That is 27 over 4x squared. Okay, so good. That is how you can do the same question with two different ways. Okay, so I have to move to the next question now. The next question is from June 16 and it is paper 12. Now, for this question, again, you need to be very good at the circle properties. It says AB is a diameter of the circle, center O. Now, if this is the diameter, then this is the radius. They are all equal. Okay, up to this. Let me call this point X here, and this point is Y, so that these are the radii here. Okay. Uh, P and QB are tangents. And this is a very famous property that the tangent is perpendicular to the diameter or to the radius. So you have a right angle over here. Okay. And now it says prove that triangle PAO is congruent to, we have to prove that these two triangles are congruent to each other. So let's guys start this proof. You have to say in triangle PAO correspondence with the triangle QBO. Okay. First of all, I can say that OA from here is equal to OB from the other triangle, and they are both radii. Okay, radii of the same circle. Reason is a must, but remember this. Now, secondly, we can say that angle A is equal to angle B. Angle A is equal to angle B, and they are equal to right angles. The reason for this is that uh, tangent is perpendicular. Tangent is perpendicular to the radius or the diameter. Okay. Now the second reason. Thirdly, I can see that this angle is equal to this angle. Okay. So angle O from this triangle is equal to angle O from this triangle, And the reason for that is vertically opposite angles. Okay. Therefore, at the end, the last line would be therefore triangle PAO is congruent to the triangle QBO. And Josefa, what would be the case of congruence this time? We have used this angle, this side, and this angle. So this is going to be,
ASA.
yeah, angle, side, angle. Okay. So that is how you prove that these two triangles are going to be congruent to each other. Okay, I think that is more than enough. I have given you the practice, and you redo these questions. Inshallah, you will find yourself good at proving or solving questions on similarity and congruence.